Nuclear chemistry. Radiation. Nucleus breaking apart, that's where the radiation comes from. And there's three types. There's alpha. Alpha radiation is a helium nucleus. It's big. It moves quite slowly and is easily stopped by things like paper or smoke in smoke detectors. So there's an alpha source in them. Beta radiation. Beta radiation is an electron. So this is quite fast, nearly the speed of light. But it's stopped by aluminium. So it's not got that much penetrating power. Then you have gamma radiation. Gamma radiation is not a particle. It's actually an electromagnetic wave. And it needs something good to stop it, something heavy. Things like lead or water. Just to demonstrate the charges that these particles or radiation have, if you got a target and you fired all three types of radiation at the target with a positive plate at one side and a negative plate at the other, you would find that the beta radiation would go to the positive plate and would travel for a fair distance. The alpha radiation will go to the negative plate, i.e. alpha is positive charge, so it would go to negative and would easily swerve off. And the gamma radiation, which has no charge because it's not a particle, would travel straight forward through to the target. Alpha decay. This is where alpha particles come from. What happens is that the unstable nucleus, in this case we're looking at uranium, will spit out an alpha particle from its nucleus, which contains 2 protons and 2 neutrons. Therefore, you can see there. Let me start off. Spit out an alpha particle containing 2 protons and 2 neutrons, and the remaining material then changes to, in this case, thorium, reducing by 2 for the atomic number and by 4 for the atomic mass, as you can see. Beta decay. In this case, what is happening in the nucleus, a neutron is spitting out an electron and changing to become a proton. So as you can see here, we've got carbon-14, which contains 6 protons and 8 neutrons. One of the neutrons spits out an electron to become a proton. So the atom of carbon-14 changes to become nitrogen, which will have 7 protons now and still has 14 atomic mass. 7 protons, now 7 neutrons. Gamma radiation is an electromagnetic wave, electromagnetic energy that is emitted when we get the above radiations happening. Half-life. There's 2 ways of looking at this. There's the time for the radiation to reduce by half, or the time for the radioactive mass that's present to reduce by half. As you can see here, if we had started with 20 grams of carbon-14 with a half-life of 5,000 years, how much will be left in 15,000 years? So we start with 20 grams. So in 5,000 years you'd have 10 grams left. In another 5,000 years you'd have 5 grams left. So in another 5,000 years you'd have 2.5 grams left. This is the easiest way I've ever seen of laying it out. You also need to be able to think of a couple of uses. Things like cobalt-16 are used in medical because they're using very short half-life, so it's not going to damage the body while it's in. And magnesium, and I can't remember the number, but it's used in things like smoke detectors. It's an alpha source, and the alpha particles are easily blocked by the smoke. Therefore, as soon as it's blocked, it sets off the alarm. The reason for using that, quite simply, is that if it's got a long half-life, you don't need to keep changing it, and it's easily stopped.